Let's kick off our journey all about energy by introducing you to a little friend of mine. We have a plant, and I'm sure you recognise this is a plant. It's a green plant, it's a leafy plant. Now, I'm not going to get into eating this at this point. The point I want to make is how this plant derives its energy. So we're thinking about energy, and we're thinking, right, where does this plant get its energy from? And you can probably have a good old guess at that, right? You probably have a bit of a decent understanding. It gets it from the sun. So the first point I kind of want to make to you is that plants derive energy from the sun. Now, you might be thinking, well, that's all well and good. What the hell's this got to do with me? I'm a PE student. I'm running around a gymnasium, or I'm in a PE lesson. I want to know about me. Well, we're going to get to that point in just a second. But plants derive energy from the sun. And I'm going to give you a little term here. I'm not going to test you on this, by the way. If you're doing the quizzing with us, I'm not going to include this, but that makes a plant what's called a phototroph. Now, that's all one word. I didn't mean to have that little space in there. But the point I want to make is that the first half of this word, photo, means light, and troph means nourishment. So the plant is nourished by light. Well, how does that compare to a person? Let's think this is you or I or a PE student or all of the PE students or your PE teacher, let's say. Here we are. This is us, a human being, an animal. Where do we derive our food from, our nourishment, our energy from? And of course, you're not going to be surprised to know that we derive that from food. So I've drawn a nice little kind of burger in here, and I just want to write in here that human beings, animals, derive energy from food. Now, nothing is going to be surprising about that, right? Now, what I do want to throw in is that we've got phototroph, which is, of course, light nourishment. What do you think an organism that takes on food would be called? And I'm going to tell you, it's called a hetero. I'll just put those little lines down again. Troph. Now, we know that troph means nourishment. What do you think hetero means? Well, hetero means other. So it derives nourishment from something other than the sun. But this is the interesting point and almost the philosophical point I want to get to here. When you are bounding around your PE lesson, when you're running an 800 meters at your best pace possible, or when you're trying to keep going and you're trying to keep going in some kind of trampolining 10 bounce routine that you've beautifully choreographed and planned, what is it? What is the sort of interesting point here? And the interesting point here is that this food, a form of chemical energy, more of which in a second, this food, of course, comes ultimately from plants. Now, you might be thinking, well, okay, I get that with the lettuce, I get that with the bun, which of course is made with wheat, but get that with the tomato. But what about, let's say, the beef or the meat that's in the middle of this? That's from an animal as well. But of course, the animal ultimately is fed on, let's say, grass and greens, and ultimately all of that energy derives from the sun. And I just wanted to share that kind of interesting philosophical point with you at this point. Now, I want to take this further before we look at that terminology down there. Human beings derive energy from food. We agree. Now, this is in the form of chemical energy. This is your chemical energy store. Thinking about this in relation to your physics studies, we are taking from the chemical energy store. We're using a chemical energy store. And of course, we can convert this chemical energy store. And we can take on, let's say, the nourishment that's in a burger, and we can convert it into other forms of energy. We can convert it into, for example, your potential energy store. Okay, and we would do that by, for example, converting this to fat and storing it in our body. It becomes a potential or saved energy store. But you can also convert it to kinetic energy. And of course, that would mean that we take the nourishment, which is in, let's say, our burger, and we convert it into movement. Now, that in your PE lessons is what you are doing day in, day out. It's what you are, it's who you are, and that is why I'm introducing this concept to you. Now, let's take this a little bit further. Energy is a requirement of all metabolic processes, so it's worth us just detailing what this means. A metabolic process, or your metabolism, it is the sum total of all the chemical reactions in your body. Now, let me be clear, there are billions of chemical reactions going on in your body. They are required for every process that your body fulfills internally, okay? So therefore, energy needs to drive that process, and that driving energy is what we refer to as activation energy. So ultimately, when we think back to our burger, we are thinking back to that which is going to provide us activation energy to be able to follow metabolic processes. Fantastic. Now, I'm going to risk boring you here, folks, because I'm going to write down something, and I'm going to write that out in hand that I really want you to pay attention to. And it is the following. Human beings human beings, it's a bit of a long sentence this, must consume, they must consume, by that we mean eat and drink, of course, we must consume sufficient, that means enough, of course, chemical energy, stuff like burgers and plants and bread and so on. So we must consume sufficient chemical energy to power, and I'm going to say all metabolic processes, all the metabolic reactions in the body, all metabolic processes. And I'm going to change colour for a crucial word here, and movement. So the energy that we take from our food that's ultimately been derived from plants that have derived that energy from the sun, that job is to power all metabolic processes and to power movement. And that is a critical point I want to make. Now, when we talk about energy, we need to think about the unit of energy. Now, we are going to use here the unit of energy of a kilocalorie. By all means, kilocalorie. By all means, you can use kilojoules as well. You could even use calories or joules. These are all measures of chemical energy, but we use kilocalories because it's a nice, manageable number for us. Now, if you're wondering what a calorie is, and you might be able to sort of derive, calore, it comes from the Latin for heat. Well, if you really want to know what a calorie is, it's enough heat or enough energy to heat 1 gram of water by 1 degree Celsius. So it's enough energy to get 1 gram of water to 1 degree Celsius. So 1 kilocalorie is enough energy to get 1,000 grams of water up by 1 degree Celsius. That's what we mean. That's ultimately what the energy construct is. Now we're going to take this a little bit further. We now want to ask the question, well, how much of this stuff do we need? If I'm going to be really efficient and effective in, let's say, my PE lesson, how much energy do I actually need? Well, first of all, I'm going to provide you with a man. Now, I'm not the best at drawing, as you probably already guessed, but here is my man. He is a man. Okay, he is a biological male. Now, this person, on average, and very much want you to focus on the word average here, this person, and we're talking about an adult man here. I mean, you guys are quite likely to be teenagers, and therefore you're sort of developing into adulthood. But on average, this person is going to require 2,500 kilocalories per day, okay, on average. Okay, now if we take that and we look at the same sort of value for a woman, nothing different between my woman and my man, apart from one is green and one is yellow, but on average, I'll just put AV there, on average a female is going to require 2,000 kilocalories per day. Okay, and I'm going to address exactly what we mean by need, but that is something that you can immediately start to consider as a relevant kind of piece of information. Now, where I want to take this next is to consider whether it's a man or a woman, what is the relationship between actual energy consumption and energy expenditure, and this is what we would call the energy balance, folks. The energy balance. And I want to be really careful how I present this to you. I want to give you 3 scenarios. Okay, so scenario 1 is where our energy intake, let's say that we're talking about how many calories we've taken in a given week, for example, and our energy expenditure, we're going to imagine that this has a relationship. Now, energy expenditure is how much energy is released through metabolic processes and also movement. Now, what I'm going to do before I go any further, I'm actually just going to save this little bit of text. Let me just copy that, Command C, there we go, and I'll come back to that in a second. But what we're going to do now, I don't know how to get rid of that little square anymore. In fact, I'll tell you what I'll do. I'll make another one, Command V, because I've now got 2 of those, and I'll make a third one, Command V. We've now got 3 of those. So my horrible handwriting pictured 3 times. So this is what we're going to do here. We're now going to make the following point. If our energy intake, how much we consume, is equal to our energy expenditure, this is going to mean that a person has stable weight, okay, how heavy they are over time. If this relationship here is that energy intake, how much we eat and drink, is greater than how much we release, this is going to mean weight gain. And finally, if we are arguing, for example, that in this example here, the person we're talking about releases or expends more energy than they consume, than they take in, this one here is going to equal weight loss. Now, all of these are indicative of this scenario over time. If you eat more food in one day than you spend in one day, you're not going to get heavier in that day, or the difference is going to be minute. We're talking about over time. So I want to imagine a situation. Let's go back to our, let's say, I think the woman I drew was in yellow. Let's go back to our woman, and we said she requires 2,000 kilocalories a day. And let's assume for a second that is an exact requirement for this individual. Well, what we could say, if I just bring my calculator up here, what we could say is if we take that 2,000 kilocalories and we multiply it by the number of days in the year, that is going to equal that this person, over the course of the year, requires 730,000 kilocalories. If this person here consumes 730,000 kilocalories in the course of a year, assuming that this is an accurate estimation of how much energy they require per day, then this person will have stable weight. And that's the point I want to make to you folks. Our objective should not be to eat exactly 2,000 kilocalories in one particular day. Our objective is over a period of time to maintain a stable weight, or we might have situations in our life where we might need to gain weight or lose weight, but we can use the same relationship in this way. So they're the key points I want to get across to you. That's why energy is so important. And I just want to get back to this principle before. I think it's so important that you accept this. Plants derive energy from the sun. Human beings eat plants or other things that eat plants and then convert ultimately that originated photo energy from the sun, and we convert it into processes including movement, which we then go and expend in places like our PE lesson. When you are in your PE lesson, folks, you literally turn sun energy into beautiful movement, technique, health, physical literacy, and you should be damn proud to do so. It's almost a miracle.